Hey guys, we're going to take a look at something called binomial expansion. So this goes along well with multiplying polynomials. In this case, we're taking binomials that are raised to a certain exponent. So either squared to the third or to the fourth, whatever it may be. You can do this by normal multiplication, where you would write out however many the exponent says. So in this case, we've got x plus 2 squared would really mean x plus 2 times x plus 2. We would FOIL and get our answer. This one would end up being x squared plus 4x plus 4. If it was x plus 2 to the third, we could write out x plus 2 times x plus 2 times x plus 2. We write that out 3 times, multiply these two things. You would first FOIL these two, which we know is x squared plus 4x plus 4, and then also multiply this x plus 2 to that value. So it would be x squared plus 4x plus 4 times x plus 2. You'd have to distribute everything. You can continue. Same thing if it were written to the fourth power. We'd have x plus 2 times x plus 2 times x plus 2 times x plus 2 4 times. Again, you'd have to FOIL, get an answer, and then multiply your results. This can become very tedious if you have a binomial raised to a certain power. So in this case, we have something called, we have a method called Pascal's triangle that allows us, gives us a shortcut to complete these problems. All right, now I'm not going to make it mandatory that you perform these expansions in this way. You can go through the multiplication each time. So if we wanted to finish out this x to the third, I would take this, multiply the x times the x squared. That would give you x to the third. X times 4x would be 4x squared. X times 4 would be plus 4x, and then multiply the 2 times everything. 2x squared plus 8x, and then plus 8. Combine like terms. X to the third plus 6x squared plus 12x, and then plus 8. Again, you can do that. That's fine. That's not a problem. But this does give us a little bit of a shortcut. Now, I will tell you, it doesn't look like a shortcut, but it actually is. So I'm going to show you what Pascal's triangle is. All right. And we've got, again, this is for binomial expansion. So this means you've got a binomial raised to a certain exponent. So if this is our binomial, if we've got a plus b, we're just using this as a generalization, raised to the 0 versus raised to the 1, to the second, to the third, to the fourth, to the fifth. There are patterns for each of these. Now these patterns are going to look kind of tricky, but I will show you some shortcuts here to kind of understand it a little bit. So again, this middle part that you're about to see is a little bit confusing, but don't worry about that so much, okay? So we do have patterns here. Remember, anything raised to the 0 is 1. So that's where we get the top coefficient here for the triangle. Anything raised to the first, you would just write it out, a plus b, so it would just be a plus b. If it were squared, this is the pattern. It would end up being a squared plus 2ab plus b squared. We've talked about this one before in our special cases. To the third, this again is the pattern, fourth and fifth and so on. Okay, again, it looks very confusing. It does look like there's a lot going on there. However, what this does is give us the coefficients for binomial expansion. So if you notice, we have this one up at the top, starts at the top, and you've got ones all along the side for the triangles. Okay? The way that we get the next row is you take the two numbers above it and add them together. So again, one's along the side. How this 2 happens is 1 plus 1 is 2. This row, the 1, 3, 3, 1, we got 1 plus 2 is 3, 2 plus 1 is 3. The next row, 1 plus 4, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then the 1 is carried down. And then finally down here we've got the 1 plus 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 5, so 4 and 1 is 5. So Pascal's triangle is giving you coefficients for a particular binomial. Okay, again, I understand this probably seems a little bit confusing, but I'm going to show you an example here to hopefully help you out. Okay, so what we've got here is we want to expand the expression k minus 5 raised to the third. Okay, k minus 5 raised to the third. And what it's going to have you do first is it wants to identify the coefficients for n is equal to 3. Again, n is our exponent here, and we're looking at row 3. Okay, well those coefficients, if we look back here, when our exponent was 3. The coefficients are 1, 3, 3, and 1. Okay, so those are our coefficients. So the coefficients for this row, again, are 1, 3, 3, 1. What I would do at this point is I would write this down as 1, 3, 3, and 1, and kind of excuse me, spread them out across the paper to give yourself a little bit of room. The next thing you want to do is identify what a and b are in the binomials. Okay, well in this case a is k, that's the first term, and b is -5. Excuse me. So we're identifying a and b. Next thing we're going to do is substitute excuse me, into this pattern. Okay, so we're going to take whatever the value of a is, which in this case is k, and then raise that to the third. Now here's the trick on these. The value of a, its exponent is going to count down. So this is k to the third. The next term will be k squared. The next term will be k to the first. And then until there's no more k. So we can write k to the 0 here, that's fine. But remember, anything to the 0 power is 1, so it's like it's not even there. So again, it counts 3, 2, 1, and then nothing. The value of b counts in the opposite direction. So we can start here and start at 0, 1, 2, 3. I usually work backwards. Okay, so the value of b again is going to go kind of the opposite direction. So I usually start from the reverse and say -5 to the third, -5 squared, -5 to the first. And again, this would be nothing, but just for this first one, I'm going to write out -5 to the 0 power. So again, the value of a counts down 3, 2, 1 in terms of its exponents, and the value of b counts in the opposite direction. Okay, so that's what you see again. It's kind of, it looks like a lot here, but that's what we would do, and then you simplify. Okay, k to the third is k, times 1 is, excuse me, k to the third is k to the third here, and then anything to the 0 is just 0. So that first term just simplifies to k to the third. Here, I'd have to do my exponents. Okay, so that would give me k squared, and then 3 times -5 would be -15k. Excuse me. On this one, I'd have to do the -5 squared would be +25, multiplied by 3 is a positive, this would be a squared, 75k. And then on the last one, again, anything to the 0, that would just cancel out, and then just be left with -5 to the third, which is -125. So, k minus 5 to the third. Again, you could go through and say k minus 5, k minus 5, k minus 5. Foil all of these together, simplify your answer. Or you can use this pattern, and it does kind of give you a little bit of a shortcut. Okay, so again, the answer for this one would be k to the third minus 15k squared, excuse me, plus 75k minus 125. Okay, let's look at a second example. This one says expand the expression 6m minus 8 raised to the third. So we're going to go through the same process. Again, you want to identify what the coefficients for row n would be, excuse me, n being 3. So those would be 1, 3, 3, and 1. Next, we want to figure out what a and b actually represent. Well, a in this case is 6m, and b is -8. Okay, now we're going to substitute those in the pattern. Again, I'm going to spread this out, so I'm going to write 1, 3, 3, 1. I'm going to take the value of a. Remember, those exponents count down, so this would be to the third. This would be to the second. This would be to the first, and this would be to the 0 power. I'm just not going to write it here. And then we take the value of b, do the same thing, but it counts in the reverse order. So we've got -8 to the third, -8 to the second, -8 to the first, and then again, it would not be there. So again, a counts down and b counts up in terms of their exponents. All right, so next we would simplify. Excuse me. So we'd have to do 6 to the third and m to the third, which 6 to the third is 216. On this one, we got to be careful. We have 6 squared, which is 36, and then multiplied by 3. It's 108, and then multiplied by -8 would be -864. And you can use a calculator for this, that's fine. And don't forget the squared with the m. And again, this term is negative because of that -8. Next, we have to do -8 squared, which is 64, multiplied by 6 and multiplied by 3. When you simplify that, you get 1152, so it's 1152, and it would be m to the first power. And then over here, we've got -8 to the third, which would be -512. So once you kind of understand the pattern and see how the exponents work, this is a little bit quicker of a method when this is binomial expansion. Okay, so again, by all means, you can still sit here and do 6m minus 8 times 6m minus 8 times 6m minus 8 and simplify and kind of go through that process, but it does take a little bit longer, and when you have higher exponents, I would really recommend this pattern. Okay, we've got one more example here. Alright, so this one, as you can see, is to the fourth power. So you want to identify the coefficients for row n, or row 4. So row 3 was 1, 3, 3, 1. And remember, how you get the next row is you've got 1s along the outside. You take the numbers above it to get the middle coefficients. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So these are the coefficients for row 4. So if you can remember row 3 or row 2, you can figure out excuse me, every other row beyond that. Alright, so we've got 1, 4, 6, 4, 1. We want to figure out what the values of a and b are. A is 3x. B is 1, and we're going to substitute these into the pattern. So we've got 1, 4, 6, 4, 1. This would be 3x. Now it's got to be to the fourth power because that's what the expansion is. If we've got a 4 here, the next exponent would be to the third, to the second, to the first, and then nothing. And then the nice thing about the 1 is I'm going to write it, but you know that the 1 really isn't going to change much of anything. Excuse me. So this would be 1 to the fourth here, 1 to the third, 1 to the second, 1 to the first, and then nothing. Okay? And we'd have plus in between all of these. Okay? So now we simplify. So we've got, excuse me, my apologies, 3 to the fourth would give you 81, and this would be x to the fourth here. On this one, we've got to do 3 to the third, and then multiply by 4. So 3 to the third is 27, and 27 times 4 is 108, so this would be plus 108 x to the third. Here we've got 3 squared, and we would have to do whatever number this is squared, however it's a 1, so again it's not going to change anything. So 3 squared is 9, multiplied by 6 is 54. So plus 54x squared. Over here, again, we would do 1 to the third, however, it's not going to change. So multiply that 3 and 4 to give you 12, so plus 12x. And then the last one would just be 1. Okay, so this is a time saver when you do have a binomial raised to an exponent. It helps out versus having to sit there and write out the parentheses 4 times and foiling and distributing. There's a lot more room for error in that type of problem.